Most students make this problem difficult because they split the fraction too early. First of all, you need to look at the denominator. So observe that we have x and x squared plus 9, meaning that means that we have a linear factor and a quadratic factor. So we can write this expression by writing a over x, that is for the first factor, then plus the second factor is a quadratic factor, so we write bx plus c over x squared plus 9. Important mistake to avoid: since x squared plus 9 is quadratic, the numerator above it must be a linear function. That is why we wrote bx plus c, not just b. Okay, so now we can go ahead and write this as x squared plus 6x plus 9. Then on the right hand side, we can combine the numerator by writing this as a into x squared plus 9, then plus bx plus c, everybody multiplied by x. Okay, so we wrote this because the common denominator is x multiplied by x squared plus 9. When you do the division, you have that expression on the right hand side in the denominator. Now here I'm not going to use try and guess, I'm going to do the expansion. So this is, if we expand on the right hand side, we get, since we have 2x squared, I can just factor out x squared and write this as a plus b. Then I put the x squared outside, plus I write the linear term cx, then plus 9a. At this stage, notice that the left hand side is the same as the right hand side, so I just compare. Look at the term without x in it. I have 9 on the left and I have 9a on the right hand side. So this means that 9a is equal to 9. So dividing throughout by 9, I get that a is equal to 1. In the same way, I compare the term with x in it. I have 6x on the left and cx on the right. So this should be the same, and they can only be the same if c is equal to 9. In the same way, the term with x squared, on the right hand side I have a plus b, and on the left side I have 4, right? The coefficient of x squared is 4, so I write this is equal to 4. But we already have the value for a, so we already have the value for a, so that is 1 plus b is equal to 4, which implies that b is equal to 3. So putting everything together, the partial decomposition becomes a is 1, that is divided by x, then plus b is 3, that is 3x, plus c is 6, not 9. c is 6, then divided by x squared plus 9. Then we can go ahead and take the integral with respect to x. Now at this stage, we can split the integral. So this is the integral of 1 over x plus the sum on the right. We can write this as 3x divided by x squared plus 9. Then plus, we are going to add this one, 6 over x squared plus 9. This with respect to x. Okay, so you will see why we did this split. So let us first of all start with the first part. So the integral of 1 over x with respect to x, this is just in standard form, so this is just a natural log of x, plus the constant of integration if we are adding a c, but we're going to add a c together, so we don't necessarily have to write a c here. Okay, now for the second part, we have 3x divided by x squared plus 9 with respect to x. So one thing that you observe is that the derivative of x squared plus 9 is what? Is 2x. Okay, we can make a u substitution. U is equal to x squared plus 9, which implies that du is equal to 2x with respect to x. So dx is equal to du over 2x. Okay, so this implies, the x in here cancels with x in the numerator, right? We remain with 3 over 2. Then the integral of 1 over u with respect to u. And this is just 3 over 2, the natural log of the absolute value of u, then plus the constant of integration, right? Which we'll not write this time because we will combine everything together. But remember, we have an expression for u, so that this is just 3 over 2 natural log of, I can just write this x squared plus 9. This will always be positive because of the square, so I don't necessarily have to write the absolute value. Now for the integral of 6 over x squared plus 9 dx, right? Here we are going to use the integral of 1 over x squared plus a squared dx, which is 1 over a, then arctan of x over a. In this case, 9 can be written as 3 squared, right? So our a here is what? Our a is here is 3. So this becomes, but we have 6 outside, right? So this is just, I just multiply this by 1 over 3, then 1 over 3 arctan of x over 3. Okay, this moment we can put everything together. The integral leads to the natural log of x, then plus, in the middle we found 3 over 2 natural log of x squared plus 9, then plus, we had 6 divided by 3, which is a 2, so we have 2 outside. Outside arctan x over 3, then plus c. Okay, so the big idea is very simple. When the denominator has x multiplied by x squared plus 9, remember to use a divided by x plus bx plus c divided by x squared plus 9 for the partial decomposition. So something to take note here is that the quadratic denominator needs a linear numerator. That one step prevents the biggest mistake in this problem.